Greetings everyone, this is Non-Expert here, back again with another video. Today we are going to be solving problem number 11 of our 30-day LeetCode challenge, and the problem which has been given to us is diameter of a binary tree. So the problem description is that given a binary tree, you need to compute the length of the diameter of the binary tree, and the diameter of a binary tree is the length of the longest path between any two nodes in a tree. So instead of saying diameter of a binary tree, let's just say that we need to find the longest path between any two nodes. And we've been given an example over here where you can see that the longest path is 4213 or 3124, whatever you want to call it. Uh, and when that happens, you can see that the return result is 3. So we are assuming that whatever's the length, it's minus 1 of that. And that's basically the output that we need to get. So our basic intuition would sort of tell us that we can solve this problem using recursion, and I think that that's right. The one thing that we need to sort of make sure of is that how we are sort of using the recursion. So if you've gone through how you want to find the maximum height of a problem or anything else, we can use the same logic as we go forward. But I'm going to be implementing something like that. There is a node given over here which is saying that the length of the path between the two nodes is represented by a number of edges between them. So we already know that, so that's okay. Um, in our essence, what we can say is that edges can be represented as whatever's the length of the path that we have sort of conjured up minus one. That would be the number of edges. So using that logic, we can sort of come up with our base conditions at least. So our base condition would be, hey, if nothing has been given to us, then we return a 0 since the expected is an int. What I'm going to do is I'm also going to maintain something called as answer, which is going to contain the answer, and eventually I'm going to return this guy. And this is going to be the length of our array, and I'm going to iterate or sort of recurse through all the values as I'm sort of moving forward, and then sort of update the max. So the way we can start over here is that I'm just going to make a simple utility function. I'm going to call it traverse, and I'm gonna employ a simple thing where I'm just going to say that, hey, if node is not there, then you return 0, which is fair. And then I go traverse on the left hand side and sort of update the values from there. So I say, hey, check the left hand side, and do see that I'm sort of returning this inside the left variable, and just do node left. And similarly over here, we can do the same thing with right. And essentially what I'm doing right now is that I'm just sort of coding up a simple solution which can just count the maximum height. But that's the exact semblance that I want to use inside our code as well. So if you sort of looked at this code before, you can see that this is one of the ways of calculating the maximum height inside your tree. But that's not what I want. Like when I go through the iterations or when I go through the recursions, what I want to do is I want to go to 1, 2, 4, and then when I go to 2, I want to know that inside 2, the maximum which I can sort of form right now is 1, because that's the element over here. Or in our sense, the way we would return this is that if left is over here and we're at node 2 and we look at left, after this processing has happened, we're going to go to 4, 4 is going to return 0, then we're going to have left and we're going to return 1. So basically in 2, we're going to have a value which is going to be associated as 1, which is basically going to help us determine that length is going to be 1. And then we can go forward over here on 1, which is the root. And since 2 was already 1 and 3 right now is going to be 0 because there's nothing going to be there, what we can do is we can add up 1 plus 1 and just sort of go forward from there. In essence, that's what's going to happen. But how do we get the sum out? So in essence, when you sort of look at all these things, you know what's going to be the inside left. So we take the example of our root. I know this is going to get a little confusing right now, but I hope you bear with me over here. So you have root over here. We already deduced that 2 is going to have another value which is going to return as 1 because it sort of fetched those values from this guy. And we know that 3 is going to return 0, right? So what we can say is, in this context, what we can say is that the length is going to be the maximum length of our path is going to consume at least one node which is intersecting between left and right, right? So it could be either 2 where it could have 4, 5 and then some 6 value over here. That could be one thing, or it could be some other value, and that's what self.answer is sort of going to contain. So if I have left and I have right, so I can also update my self answer to take in whatever is the maximum between self.answer and also left plus right plus 1. So basically you're saying that give me what's the length of left, give me what's the length of right, and then sort of also add them all together, and that's what I want. So I know I can understand like this being a little confusing. So let's do a quick print of what's the left value or sort of where we are presently at. So let's do node.val, let's do left, let's do right, um, and let's do what's the answer so far. This will sort of get us in place of understanding what exactly is happening. So do remember the tree structure, and you can see over here the first thing which is being processed is 4, which is absolutely correct. The max that we've set is 1, so nothing has been changed over there. You can see left and right are returning 0. Same thing with 5, they're returning 0. But when we come at 2, 4 and 5 are returning 1 and 1, which is pretty awesome. So if you look at that value, which is 1 and 1, you can say that, hey, if I just include 2, so we have a path of 4, 2, and 5, well, the length should be 3. And it's computing that properly because it's calculating what's the sum of left plus right plus 1, which is the node itself. And then you sort of move forward, then you look at 3. 3 is returning 0, 0, which is fine because it does not have any left or right elements. And when we come at root, 2 is being returned from the second element, which is the left, and 1 is being returned from the right, and then 4 is the sum which we're going to get eventually. And after we do all these processing, we know that the length minus 1 is the number of edges, so that's basically the answer over here. Let's just go ahead and run this. Hopefully this should run fine. I'm assuming that it would, unless we sort of messed up somewhere. But I hope that you understand the overall logic of it. I know it can get a little tricky. And the essence for me is this guy over here. Once I sort of deduced that I want to do left and I want to do right, then it became a lot more clearer. But let's just go ahead and submit the solution. And awesome, you can see that this has been accepted. I hope that I was able to explain this problem. I know it's really difficult to explain this problem, but when you sort of do a dry run on paper on your own, you'll get a sense of what's really happening as well. So that's it for today's video. If you did understand something, you can leave it in the comment section below. And if you did like this video, do give a like and do subscribe to our channel. We are discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.